Be better if it was ASS. That'd be hilarious. Like, that would be so funny if that was someone's initials. It'd be really funny. I'm assuming you want method first. Take logs of each side. Just a reminder, that's like saying take a square root of each side. So we put physically a log on each side. Step 2, expand using log laws. Expand using log laws. Take a peek on step 2, what we did yesterday with log equations. Simplify, now we're expanding. So this is where your head's going to start to be like, blah, what's going on? So just a really, really quick review of expanding. Exponents become coefficients. Multiplying becomes addition. Division becomes subtraction. Step number 3, move all variables to one side. Move all variables to one side. So yesterday's step 1 is now step 3 today, hence where your brain's going to be all confused. Step 4, isolate x. And step 5, which is not in red pen like yesterday, is use your calculator. Nice.
I love doing that.
These don't have that check because they're not what we call special equations. Logs are special, exponential not so much. The nice thing about these, same 5 steps are going to work every single time. You're going to see once we do a few, they become very repetitive. So let's start with a super easy one, and then we'll work up to the harder ones. So we've actually already done special equations. We started the unit with them. The difference about what we're doing now is there's no common base for these guys. There's no way to take 40 and turn it into an exponent with 5. And so when there's no common bases, we go to these new steps. So step number 1 is take logs of each side. I'm going to physically write the word log on the left and write the word log on the right. What you do to one side of an equation, you do to the other. Now, I chose a base of 10, but in theory, you could choose any single base you wanted. Why did I choose base 10? Because it's what your calculator knows. So you could choose to put a log base 3 and a log base 3. You could put a log base 100 and a log base 100. It just means at the end, you'd have to do change of base theorem. Why bother? So that's why we pick a base of 10. So there's step 1, log each side. Step number 2 is expand using log laws. The first thing we do is any exponents are going to drop down in front. So this becomes x log 5 equals log 40. That's the sole purpose why we have logs. Logs is the only way to take an exponent and make it part of the main equation. Log is the only function that will take an exponent and drop it down into the main equation. That's the sole purpose of logs, is to be able to solve these. Why do we need to solve these? That'll come after Christmas. You've got to wait 2 whole weeks. The anticipation. No.
And that's where the TV comes in.
Step number 5, all variables on one side, anything without a variable to the other. So we're done because all my x's are onto one side. Step number 4 is isolate x. So how do I get rid of a multiplication by log 5? Divide by log 5. This now becomes calculator question. If you have the old operating system, you're going to have to bracket at the end of each log. If you've got the new one, it will do it for you. So grab your calcs. You're going to hit your log button 40. Divide by log button 5. What's the rounding instructions if the question does not say otherwise? 3 decimal places for log questions. 292. That's rounded to 3 decimal places. You're always going to get wacky decimals for these guys. Because if you think about it, what's 5 to the 1? 5, that's too low. What's 5 to the 2? That's too low. What's 5 to the 3? 125. So we know it has to be between 2 and 3, and that's why you'll always get really funky decimals down here. Rarely is it going to be a nice even number. If it was going to be an even number, this would have been a common base question. Okay, so logs are typically whole numbers. Exponential equations are typically decimals. Waiting. Yes. Because 5 to the 2 is 25, and 5 to the 3 is 125. And 40 is halfway, not quite halfway, but in between those two. Okay, so log equations from yesterday are typically whole numbers. Exponential equations are typically really funky decimals. Number 2. I'm going to number the steps for this one because we're going to have all the steps. Step number 1 is take a log of each side. So I'm going to literally just write the word log on the left and write the word log on the right. Just repeating, you can use any base you want in the world. I chose base 10 because it's what our calculator is programmed to calculate. Step number 2 is expand using log laws. So first thing, exponents become coefficients. So I have an x log 4. Now be careful here on the right-hand side because I need to bracket that exponent because he's a binomial. Okay, if I left it without the brackets, that's a half mark off on the exam. What can I do here on the right? Can I distribute or not distribute? This is always the big log question. When do you distribute and when do you not? I can because it's in front. So I'm going to multiply that log 3 through. So I get an x log 4 on the left. On the right, I'm going to have 2x log 3 minus log 3. When can I not distribute? And that's going to happen in log equations. It's not going to happen in exponential equations. Step number 3, everything with an x onto one side, anything without an x on the other. Now this is where your brain's going to start to get confused because yesterday we put everything with a log together. That's not the way it works here. We want to put anything with an x. So I'm going to highlight this term has an x and this term has an x. So what that means is I need those two on the same side. That last term that doesn't have an x, he can stay by himself on the other side. Okay, so just repeat, yesterday we moved all the logs. That's not what we want to do here. We just want to put all the x's onto one side. So I'm going to keep my x log 4 on the left. How do I move this 2x log 3? Well, right now I'm adding him, so I'm going to subtract him. And he just comes as a whole group. What do I do with this minus log 3? He just stays on the right, hangs out over there by himself. So just to repeat, why did I not move him? There's no x. So everything with an x to one side, everything without an x to the other. Step number 4, isolate x. Whoa, how? I got a log 4 here. I got a 2 in front of this one. I can't subtract a 4 with a 3. If I move them to exponents, well, then I'm going way back up here, and I don't want them as exponents. I want them down in the main question. I just need to get that x by himself. How do I get him by himself? Common denominator, well, there's no fractions, so I can't common denominator him. So I got an x here, and I got an x here, and I need to get him all by himself. Subtract what? Okay, can I divide by a variable? And what's happened if I do divide, I'm going to end up with him on this side. I can't do that. I want him on the left. What's the only way to get that x by itself?
I think I know it, but I don't know the English expression.
Say it in German. We can laugh. Glockenspiel.
Ausklappen.
So if you have 2 terms and they have something in common, what's the only way to get that common? Oh, what now? We're going to put that in big letters.
Oh, that's not.
And I'm going to come back to where we did the method, and next to step 4, I'm just going to put in brackets factor, because it's usually what we're going to end up doing. Again, your brain's going to want to divide, subtract, do a whole bunch of crazy things. None of it's going to work. The only thing you can do here is common factor. Okay, so that x is what's common, so I'm going to bring him out front. So x log 4 divided by x, just log 4. 2x log 3 divided by x, 2 log 3. At this point in your brackets, you shouldn't have an x anywhere. If you've got an x in your brackets, you've done something wrong, because that's the only way to get this x out front. Okay, still need the x by itself. How do I get rid of a multiplication by log 4 minus 2 log 3? I'm going to divide by log 4 minus 2 log 3. The hardest part of these questions is getting that into your calculator correct. Sometimes we're going to have up to 6 logs, and there's going to be fractions and all this stuff. It's just figuring out. Again, if you have the old operating system, you're going to have to close a bracket after every log. You're also going to have to bracket the top and bracket the bottom. If you've got the new one that just gives you the nice little fraction, it's a lot easier. So on the top, we need a negative log 3. And on the bottom, we need a log 4 minus 2 log 3. This is the hardest part, is getting it into your calculator.
1.1355.
There's our offer. Sounded confirmed already? If you didn't get that, you need to tell someone so we can figure out why. Common errors are not enough brackets, too many brackets, putting a subtraction instead of a negative at the front. Okay, so if you didn't get it, check the calculator if someone around you has the same calculator. Is that a high five? That makes me happy.
And then I'm back here in the corner.
In your island, on your island.
I'm just here on the island with a calculator with a new operating system.
Everybody got 1.355. Don't be shy if you didn't. We'll just mock you a little bit, but then we'll help you. Again, if you didn't get it, figure it out, because they don't want your calculator to be the reason you don't get this question correct. Oh, I guess this was step 5. How we doing? Doing good? Yes, they're paper wasters. But they're oddly satisfying. Step number 1. What do we do first? So here's how I cheat. I literally just tuck it into the question because I'm too lazy to rewrite it. Because I know right away I'm going to be dropping those exponents anyway. Step 2, expand. So exponents have to come down. If there was any multiplying, it would become adding. We'll do one like that in a little bit. Any division would become subtraction. And I just lost myself a half mark. Yeah, anytime it's a binomial, you have to bracket it. And you have to wahoo. Oh, you knew already. I'm so obvious. Distribute or not distribute? How do you know? Because it's in, well, the brackets are in front or the log is behind, so we're going to distribute this guy through. Just blew my nose right into the video. Oopsie. Sorry, Michaela. 3x times log 2. Yep, just smush it all together. 3x log 2. Don't overthink how that goes together. Oop, plus log 2. Equals x log 5. x's on one side, anything without an x to the other. So what would you like to move where? You want to take this guy over? Okay. And if you're going to get stuck, this is the point your brain's going to get stuck. And you're going to start to, what do I do? Do I subtract? Do I divide? What do I do with these x's? The only thing you can do is factor it out. That's the only possibility with the log equation. So x is going to come out front. Log 5 minus 3 log 2. And divided by then we do Andrew's favorite part, the calculator. And we're not going to be scared of funky decimals because these always come out to be decimals. If they were nice whole numbers, it would be a column-based question.
Yeah, I could do 1.475.
475? Sounds confirmed? Can logs be negative?
No.
So what do we do? Well, we said yesterday we can't have logs of a negative number. We crossed it out. What? What do you mean we don't cross it out? So you have to remember what you're doing here. And this is an exponent. Can you have a negative exponent? Sure, we're A-okay with that. So resist the urge to cross out here. This is your final answer. Negatives are A-okay with log or exponential equations. Correct. Number 4, 19x minus 5 equals 3x plus 2. Okay, you walk me through it. I'll write down, I was going to say whatever you tell me. I'll write down almost whatever you tell me. Okay.
Move the exponents to coefficients.
Okay.
So x minus 5 in brackets log 19 is that? Yeah. Equal to x plus 2 brackets log 3.
Why?
Because it's inside, it's outside. Math there. 19x log 19. X 19 again.
Minus 5 log 19 equals x log 3 plus 2 log 3.
Just going to pause there for everyone to catch up, make sure we're confirming that that's correct. Okay. X is on one side, anything without an x on the other.
Log 9, that, yeah.
Okay.
So x log 19 minus x log 3 equal to 5 log 19 plus 2 log 3. Go up to x.
Yep, you're just one step ahead. Just want to wait, give time everyone a chance to catch up. Your brain's going to start to want to do some funky stuff here on the left. I've seen things like x log 16. Okay, nope, can't do anything except.
X log 19 minus log 3. I said x. So divide out the log 19 minus log 3 on both sides.
Now again, in exam panic, what your brain is going to see here is the log 19 on top and on the bottom, and the log 3 on top and bottom. And what is your brain going to want to do? Can we cancel? Why not? We don't want to kill puppies. You're never, ever going to cancel anything here. So we're not going to cross this out. If it was that easy, we wouldn't need our calculator. Hardest part is getting that into the calculator properly. Okay, 2 offers there. Got 3 answers now. Told you this is the hardest part. It's getting into the calc.
I got 9.1666.
Okay, so if you didn't, try it again. If not, check with someone sitting around you.
Except no one's sitting around me. I plugged into the X.
So it could be just one bracket. If you miss it, changes the whole answer.
I got that.
So when I was in grade, I feel better. Just makes me feel better, that's all. Eric.
So you think evil Eric's in jail now? Alex, one of my pet Eric for making our butt worse.
It's because you don't have a water bottle.
I'm sorry, what is this? I don't like this.
It's clearly the lack of water bottle.
Yeah, no, I have.
Oh, okay.
That's what your brain's going to want to do, but that's not right.
What?
No,
Six
no,
squared.
no.
Is it 2 log?
Bad maths.
6 2x.
What comes first, exponent or multiplication? So we cannot multiply that because we don't know what the exponent is. It's what you're going to want to do. So you want to make note, no, no. What do? We follow our steps. What's step 1? Log each side.
Okay. That's not bad.
Step 2, no expand. This is now an expanding question. I don't do exponents first. What I do is I split up that 2 times 3x. If I'm multiplying, it becomes addition. So this is going to become log 2 plus log 3x. And then in a second, I'll drop the exponents. I just want to do it step by step. Again, your brain's going to want to multiply them because you see 2 things together. It's our natural instinct. Resist the urge. This becomes an expanding where multiplying becomes adding. Now we're going to drop the exponent. So this x is just going to be in front of the log 3. It's got nothing to do with the log 2. And this guy on the right is going to be in front of the log 5. So I end up with log 2 plus x log 3 equals brackets x minus 1 log 5. That's why we practiced expanding, because we need to do it in a question like this. Now what? Oh, okay. Why can I distribute here and I couldn't yesterday? Because it's in front of the log. Non-x is on the other. What do you want to move where? This one here? The x one to there? And? Okay, so I'm going to have an x log 3 minus x log 5. And this one I already had a negative log 5 minus log 2. Can I cancel the log 5s? What? Why not? What? But there's one on the top and one on the bottom. But it'd be so much easier. You'd kill a poor puppy.
Good.
Sorry, I didn't hear 1 point.
4.50.
I got 4 points because of rounding. I got 4.5 away.
Yeah, 4.5 away.
Okay, I got something different.
I get 1 bracket can change the whole answer. 1 nasty little bracket.
I got negative 1.
Check the bracket.
Some people are questioning this 8 or 7. What did we decide on?
8.
It's 8.
It's 8 because the 5.
Okay. Again, if you're not getting that, check the calculator, someone around you, see what you type differently.
I don't see 5 as rounding up.
5 is rounding up. 0 to 4 rounds down, 5 to 9 rounds up. Sorry, that's the rule. 5 goes up. 0 to 4 goes down. 5 to 9 goes up.
Those are just the rules that I deal with since elementary school.
No, 6, 8. We got this all back. 4. Subtraction.
I hate that one.
Look at the nastiness going on here, number 6. Yeah. If it was 1, it would be a common base question. It wouldn't be this hard. Can I do anything with this? Yeah, step 1 is log each side. It never ever says simplify first. It's always throw a log on each side. And I just bracketed just so you understand it's log of all of that stuff. Okay, the right-hand side's easy. It's what's going on here on the left. So let's go step by step. If I'm dividing, I end up subtracting. So I'm going to have log 12x minus log 2 to the 5x minus 3 equals log 7. Does everyone understand where the 2 logs came from and why we're subtracting? Now what? Okay, exponents into coefficients. Now what? Now, you need to be careful here with this negative, because if you don't understand that he applies to that whole bracket, you're going to end up with the wrong second term. What I do for my brain is I actually move this log 2 in front so that my brain sees I'm not distributing log 2. What are we distributing? A negative log 2. So we're going to have that x log 12. Here we're going to have negative 5x log 2. Here is what you're going to miss if you don't catch this negative. A negative log 2 times a negative 3 is a positive 3 log 2. But it's a negative times a negative.
No, I'm saying that what I do is I just I left the negative there, then I just ask.
As long as you've bracketed and then you distribute, that's fine. This will always happen when you have a quotient question at the beginning. You'll end up with one of these double negatives. Okay, what are we thinking now? Take him over. Are you seeing the theme happening through all these questions? Right, it's always repetitive, the same thing, factor out the x. Oh, you're just a tiny bit ahead of me. Say it again, Andrew, point.
136.
Looking for confirmation. Aren't these oddly satisfying? Like you do all that stuff and you get out this magical number. Show me your thumb. How are we doing so far in exponential? Grab the little foldable guy from yesterday. Same deal. We're going to open up the second flap. What goes on the top?
Methods.
What goes on the bottom? Whatever the hardest example is for you.